So section 1.3 is going to discuss how we actually collect data, survey samples, how you find your data is a big subject. You can take a whole course in it in graduate school level statistics. It's pretty complex and all you're going to get is a few minutes. So we're just going to really scratch the surface. Let's talk about some of the ways we have of collecting data. Now, the first thing I want to do is I want to draw a distinction between types of samples. You could have a simple random sample is ideal. It's what's required of a lot of the tests that we use in this course. And a simple random sample is selected in such a way that if you were taking a sample of size 10, that every group of size 10 could be represented. So, or every group of size 10 could be pulled. Now in a class our size, that's going to be a pretty big number. And let me just calculate that for us out of curiosity. If I have 30 people in this class and I'm going to choose 10 of them, wow, then we're going to have an awful lot of ways we could choose that group. So that'd be 30,045,015 different ways I can choose a group of size 10 out of a group of size 30. Now, if you're impressed by that calculation, don't be too impressed. You're going to learn to do it later. But for now, let's go back to this problem or this idea, simple random sample. That means all such group of size 10 or whatever size can be selected. Now, if you can't meet that standard, maybe you'll still meet this other standard, a random sample. And the thing about a random sample is that the only requirement is that each individual member has an equal chance of being selected to be in your survey. So that's not as strong as saying every group of the same size has an equal chance of being chosen. That's a much stronger condition. And to kind of highlight that difference, let's look at systematic sampling. In systematic sampling, you're going to pick every kth element in your population. So in this case, if this is our population, then we could pick every third element. Now by starting here and then picking every third element, I only get 2 people in my sample. But if I started with this person right here, or maybe the first person, I could get more people. I could get 3 people in there. So first person, skip 3, fourth person, skip 3, and get the 7th person. But I can't get just any old subset that I want. If I was trying to get, take a look at the probability of getting these 2 people in my sample, that's not going to happen because they're standing next to each other. If you're picking every second or third person, then that group that's right next to each other can't be a subset, can't be a group that's chosen to be in my sample. It just won't be. And what that's saying is that this is a simple random, a random sample, but not a simple random sample, because not every group of size 2 can be in our sample. It just won't be. So what I'm trying to highlight here is the difference between a random sample and a simple random sample. Now, other types of sampling. Random samples, maybe you have a list, the computer picks your telephone number out of a list. Everyone has an equal chance because you're generating these numbers at random. So a nice random sample. Each person has an equal chance of being in there. Convenience sampling, can always smile at this one. Somebody's just yelling out the window, hey, what do you think about this? All right. Those tend not to be very accurate. Stratified sampling, definitely a good one to work with in statistics. A lot of times you divide up a population into a bunch of different subgroups, and then you make sure that you sample at least a certain number of people within each subgroup. So if you know there's a lot of minority populations, you want to make sure that you target those minority populations so that they're equally represented, or at least well represented in your final sample. Cluster sampling. What you do is you divide up your population into clusters. So here they're using voting precincts, and you randomly select some precincts, but then sample everybody within that precinct. So that would be cluster sampling. A lot of times these methods of sampling are used together. That is, you have stratified sampling within cluster sampling, etc. They use layers of these things. It gets very complex. But we're just going to kind of keep it simple here, look at a few examples, and look at some of the homework with those examples, or look at some of the problems in the homework with those. So let's flip over to the right page and do a few problems regarding sampling. So that's jumping up to page 33. So if you're following along in the book and you want to move along with me, we're going to jump up to page 33. Is it just me, or are you guys having a problem with this? Takes a few seconds to render.
Yeah, me too.
It's really slow.
It's pretty slow, yeah.
All right, that's good. Because I was getting a little annoyed. I'm like, you know, I upgraded my internet, everything, because I knew there were going to be a lot of demands on this. So, okay, we've got a lot of choices here as to the type of sampling represented. Let me just back up a second here and show you those choices again. Let's see here. So, in exercises 9 through 20, identify which of the types of sampling is used: random, systematic, convenience, stratified, or cluster. And the first one, let's do by process of elimination. Let's eliminate what is not, because your first inclination here might not be correct. And I think it'd be better to try and eliminate a few rather than pick the right one right away. So let's flip back to a study by Sheer Height, wrote a book a long, long time ago. The sexuality of women was discussed in Sheer Height's book, Women and Love, A Cultural Revolution. Her conclusions were based on a sample data that consisted of 4,500 mailed responses from 100,000 questionnaires that were sent to women. So let's see about stratified sampling. Are there any strata here?
No.
No, I don't see any strata. So we can eliminate strata. What about clusters? Do they target a bunch of clusters here with these women?
No.
No.
No. All right, so we can eliminate those two. Is it systematic in some way that we can see?
No.
Not really. So we're getting down to random sample and convenience sample. And it doesn't look like she had a computer list and picked out names somehow.
No.
So it's kind of eliminating random sampling. What are we left with?
Convenience.
Convenience. Yeah, that's it. It's a convenience sample. Let's use this for something a little bit more, though. Are we okay with the fact that this is a convenience sample? It's just the people who responded. So she took it. What is wrong with basing conclusions from her data set? This is something we did in section 1.1. So think back to what we did there.
You said that people may not be as willing, if they feel a certain way, they may not be as willing to answer the survey, so she's not getting a true population.
Okay, that's getting at it. Somebody put a
It's
little fine point on it.
voluntary.
It's voluntary. Absolutely right. It's voluntary response, right? People had to say, okay, yeah, I'll fill it out. Now look at the response rate. Did she get a good response here?
No.
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 95% of the people mailed this, threw it in the circular file. They're like, no, I'm not going to answer it. So if she's basing her conclusion on the 4,500 women out of 100,000 who mailed it back, do you think those conclusions are going to be representative of women in general?
No.
I would say probably not. It's a voluntary response, and you got such a low response rate. So the fact that you responded kind of makes you unique. You felt some emotional need or reason to respond, and I think that makes this data set unrepresentative of women in general. I could be wrong, but I'd be really, really cautious about the conclusions that she reaches in this book based on her data set. So, okay, let's keep going. So, problem number 10 was convenience. Let's look at problem number 12. The author surveyed a sample from the population of his statistics class by identifying groups of males and females, then randomly selecting 5 students from each of those 2 groups. What kind of sampling does this represent?
Stratified sampling?
Got a vote for stratified? Is there a second?
Would it be cluster maybe?
No, I think it's stratified too.
All right, so we got a 2-to-1 and 29 abstentions, or 27 abstentions.
Cluster.
Cluster? So to be a cluster, you'd have to identify groups within the class, and then randomly select some of those groups and survey everybody in that group. So is that what's happening with the survey here?
No.
Yeah, I don't think so. This one's a stratified sample. You say, okay, we got males and females, and then we're going to target so many within each strata. Okay, I'm debating on the Latin there, strata or stratum, but we'll go strata. Let's continue. Let me jump down to problem number 16 there. Deforestation rates. Satellites are used to collect sample data for estimating deforestation rates. The Forest Resources Assessment of the United Nations Food and Agricultural Organization uses the method of selecting a sample of 10-kilometer wide squares at every 1 degree intersection of latitude and longitude. So,
Would that be systemic?
Yeah, systematic. Yeah.
Sounds pretty systematic. It's like, okay, wherever those 2 lines cross, we're going to take a sample right there. So that'd be systematic. Absolutely, systematic. And one last one, problem number 20. The New York State Department of Transportation evaluated the quality of New York State thruway by testing core samples collected at regular intervals of 1 mile. What kind of sampling is this one?
Systematic.
Yeah, systematic.
I go with systematic
agreed.
as well. All right, systematic again. Awesome, awesome. Okay, let's pause here for a moment. So the last little bit we're going to take care of in this section is talking about the difference between an experiment and an observational study. So, you know, the difference is almost hinted at in the title of these 2 things, and that is, in an experiment, you're applying a treatment to your group and then observing its effects. In an observational study, you don't modify or change anything. You're just going to look at a group and collect data from that group without touching them in any way. So let's take a quick look at a couple problems between experiments and statistics. And let's see. Let me back up because I think there's a early problem we can get, maybe number 6. I've got that right. Okay, so we got to look at a study of an association between which ear is used for cell phone calls and whether a subject is left-handed or right-handed. The study is reported in Hemispheric Dominance and Cell Phone Use. So what do you think? Problem number 6 asks, is the study an experiment or observational study? What do you think what's going on here for problem number 6?
Observational?
Yeah, because we're not really adding anything, right?
No,
Yeah.
you're not changing the circumstances. You're not, giving them a headset that's left-handed or right-handed or something like that. You're just saying, okay, let's look at the data. So this one's an observational study. And from here, we'll jump up to problems 24 and problems 26. So I'm thinking I might need to jump up 2 pages. We'll just take a chance at that. Jump up to page 34. Perfect. Problem number 24. A medical researcher tested for a difference in systolic blood pressure levels between male and female students who were 12 years of age. She randomly selected 4 males and 4 females for her study. So again, observational study or experiment.
Would it be observational?
Got to vote for observational?
Yeah, observational.
Observational, yeah. You're not modifying them in any way. You're just collecting data from them. Cool. Atkins weight loss program. An independent researcher tested the effectiveness of the Atkins weight loss program by randomly selected 1,000 subjects using that program. Each of the subjects was called to report their weight before and after the diet.
Observational again?
I'm
Or
a little torn on this one. It's
Is
not
that-
quite as clear as I'd like, but
Wouldn't
you
it
put
be
it on the
observational because you're not necessarily telling them to change their diet plan because they're already on it?
right.
Well,
but you're measuring their weight before and after the diet, right? So isn't that changing
Yeah,
their circumstances?
I would think so.
yeah, because you're giving them like a diet, so which you're adding on something they don't
Yeah.
have. So
Yeah, I say because they're going on this diet, you measure them before and after, that's changing their circumstances, and that's an experiment in my mind. Yeah, what really does it for me here is the before and after. So you're comparing those things by changing their circumstances.
But wouldn't they already be on the diet? It's not them putting them on the diet. Because
Well,
they're already doing it by themselves. It's not the researchers
I agree
asking
that
them to do it.
they chose to be on the Atkins diet, but what I'm seeing is that you're looking at things before and after the diet. And so there's an intervention there, and that intervention is the diet. Even though they kind of chose that maybe for themselves, it still feels like you're changing their circumstances. So there is some experiment going on with their weight. So like I said, this one's not quite as clear as I might like. So maybe we should do one last one, problem number 28. Is there any more discussion on problem 26 though? Problem 28, the Pharmaceutical Research and Manufacturers of America wants information about the consumption of various medications. An independent researcher conducts a survey by mailing 10,000 questionnaires to randomly selected adults in the United States, and she receives 152 responses. Yeah, that's even worse than the sheer height example earlier in terms of response rate. What do you think? Observational study or experiment?
Observational.
Yeah, I don't
Yeah,
see,
observational.
I agree. Observational.
yeah, I agree. It's observational. Wow.
So can I ask a question? Just
Sure. Yes.
so the observational versus an experiment is just basically if there's any type of manipulation at all, it is experiment. But if it's just
Yes.
kind of watching it, then it's clear observation.
Yes.
Okay, thank you.
Mm. Mm. Okay. Yeah, that's it for section 1.3. I'm sorry that at least in the book there wasn't a better example of an experiment. Quite often though in experiments, one type of experiment you'll see is what's called a double-blind experiment. And that is you have a group of patients and you divide that group of patients into two groups. One group receives a placebo, which means like a sugar pill, and the other one receives an actual treatment. And it's called a double-blind experiment because the doctors don't know which pill each person gets. And that way, any result you see is not because of experimenter bias, where you're like, oh, yeah, this looks effective. Yeah, you look thinner, or you look healthier, or you seem smarter. So you're trying to reduce that bias because neither the researcher nor the patient knows what they're getting. Sometimes there's a placebo effect that just by getting something, people feel better and healthier. So you want to try and eliminate that as well. And you can do that with a double-blind experiment. But so that does it for section 1.3. Anything else? All right, good deal.